In this video, we're going to explore how to use probability rules to calculate the chances of having certain offspring with certain characteristics instead of making Punnett squares. So Punnett squares sometimes are tedious, especially when you have to do dihybrids and trihybrid crosses, or even larger ones. But with probability rules, you can do a simple mathematical computation and you can figure out the answer. So remember that when we do Punnett squares, what we're really doing is a visual way of calculating a probability. So for example, if you have a cross between two heterozygous individuals, big T, little t, crossed with big T, little t, and you want to figure out the chances of getting big T, you can make a Punnett square. And what you'll see is you get 1 out of the 4 Punnett squares will be big T, which means 25% chance. Mathematically, here's what you're actually doing in your head. From this parent, the one that I just underlined here, let's call this parent 1, what are the chances of getting big T? Well, you're doing half a chance because there's two possibilities. There's big T or little t. It's like flipping a coin, heads or tails. So there's half a chance of getting big T from the first parent there, and also half a chance of getting big T from this parent here. So in the world of probability, when you want to figure out, well, what are those two chances together, the chance of getting big T and big T, you multiply the individual probabilities and you'll find that you get 1 out of 4. You'll do half times half, so half over here multiplied by half over here, and that gives you your 1 over 4 chances. And so that's how essentially the probability rules work instead of having to use the Punnett squares. I'm going to go over the different probability rules with you. There's an addition rule and a multiplication rule, and then we're going to do a few examples together. So the first rule that we're going to go over is called the multiplication rule or the product law. We usually use this rule to figure out what are the chances of two things happening simultaneously together. So in our example here, we have big R little r crossed with big R little r. And let's say I want to find the chances of getting little r, little r. Well, for that to happen, I have to figure out what are the chances of this parent giving little r and this parent giving little r. So usually when I have the word and in there, I know that I'm going to use that multiplication rule. So I'll start with this parent here. The chances of getting little r from this parent is simply half because there's two gametes there. So it's 1 out of 2 chances. And the chances of getting little r from that parent is also half. So when you do half times half, you get 1/4, 1 out of 4, or 25% chance. And that's exactly what you see in your Punnett square. You get 1/4 chance or 25% chance to get that individual. You could do the same thing with the big R, big R. It's half and half. So we multiply them together and we get 1/4 or 25% chance. You'll notice it doesn't quite work out with the heterozygous individuals. With the heterozygous individuals, there's actually a larger chance of getting the heterozygous individuals in this particular cross. And I'll show you why by explaining the next rule, which is called the addition rule. So the addition rule is to figure out what are the chances of 2 or more mutually exclusive events happening. What that means is, let's say you have event 1 and event 2. They can't happen at the same time. So it's 1 or 2 happening. 1 or 2 happening. To figure out what are your overall chances when there's multiple choices, you have to add them together. Let me show you what I mean by that. Let's do the example of the heterozygous cross. 2 heterozygous individuals. And if I were to ask you, what are your chances of getting big R, little r, you might think, well, I'll just do half a chance here times half a chance there. But that's not the only way to get big R, little r. There's actually 2 ways to get big R, little r. The first way is, let's call this one mom, and let's call this one dad. The first way is, what if mom gives us big R and dad gives us little r? So for mom to give us big R, that's half a chance. And for dad to give us little r, that's half a chance. And so that's 1/4. Now that's one way the heterozygous individual can form. But in this situation, there's another way the heterozygous individual can form. Dad could give you big R instead, and mom can give you little r. So it's half a chance of getting little r from mom times half a chance of getting little r, big R from dad, and that's 1/4. Now, if you become a heterozygous individual from this cross, you're not going to form from both of these methods. You're forming from this one or this one. So to figure out the heterozygous crosses, or the chance of getting the heterozygous from this heterozygous cross, you have to use the addition rule. So we take our chances from the first situation, mom giving us big R and dad giving us little r, and our chances from the second situation, and we add them together, and what you get is 2/4, which is 1/2, 50% chance. So in the cases where there's multiple ways to get a particular outcome, what you need to do is you need to add the probability of the different ways together. And those multiple ways are mutually exclusive. What that means is they don't happen at the same time. To become heterozygous, this happened to me or this happened to me, not and this happened to me. And so that's the addition rule. You're going to use that in the cases, again, where you have multiple ways for something to happen. And so we're going to go and do a few examples together of these different probability rules and see how they're actually a bit simpler to use than having to draw a Punnett square every single time. And this will save you a lot of time in multiple choice, also in short answer questions. And this is the way that you're expected to do it in university as well, because you won't just be limited to dihybrid crosses, you'll do trihybrid crosses, tetrahybrid, pentahybrid, hexahybrid, heptahydrid, so on and so forth. And you won't want to have to make a giant Punnett square because you won't have time. It'll take you an entire hour to do that. So these are some general tips that I'm going to provide to you before we go in to explore some of the problems. So usually you want to use the multiplication rule when you want to find the chance of a particular genotype. So if I say, what are the chances of getting big A, big A? You want to use the addition rule to find the chance of getting, well, different genotypes together. And I'll show you what I mean by that with some more sample problems. Or you also want to use the addition rule when you have a heterozygous cross in a monohybrid heterozygous cross. And so that's what I just mentioned over here. So let's go over these examples together. So we have a cross here between big A, and little a, little a. I'm going to do a Punnett square just to show you that our probability rules actually work out. So I'll put big A up here, and little a over here. So we got big A, little a, big A, little a, big A, little a, big A, little a. Now, again, you don't have to do this if you're using probability rules, but I'm just showing you that it will work out. So what are the chances of obtaining offspring with little a genotype? Well, let's take a look. Let's start off with our first parent. Let's call our first parent mom over here, and our second parent dad over here. We want to obtain little a. So let's look at mom over here. Can she give little a? What are her chances of getting little a from mom? 0. So 0. And what are the chances of getting little a from dad? Dad will give you little a all the time. So when you have a 100% chance of getting little a from one of the parents, you just put 1, because we're using our fraction form. 1's the highest. So we have 0% chance from mom and 100% or 1 from dad. When you multiply those together, that's 0. There's no way to get little a from this cross because mom can't give you little a. What are the chances of obtaining the offspring with little a, with big A, little a? So from mom, you need big A from mom and little a from dad. So big A from mom and little a from dad. So the chances of getting big A from mom are 100% times the chance of getting little a from dad, 100%. That means you have 1 out of 1, or 4 out of 4, 100% chance of getting big A, little a. And that's exactly what we see on Punnett square as well. What are the chances of getting big A, big A? Well, you can see that here. You can see that for big A, to get that you need big A from mom and big A from dad. So from mom, it's 100% chance. From dad, he doesn't have any big A's at all, so it's 0. So 1 times 0 is 0% chance. The chances of having offspring with the recessive phenotype. So you have to just translate what that means. You got to think a bit. The recessive phenotype means that you must be little a, little a. And we already discovered here that the recessive phenotype is little a, so we can't have that. 0% chance. The dominant phenotype, well, there's a few things that could mean. That can mean big A, or big A, little a. So this is a or situation. First, we'll find the chance of getting big A. So big A from mom, 100%, and big A from dad, but dad didn't give any, so it's 0. The other possibility to have the dominant phenotype, the or, is, let's see, big A from mom is 1, little a from dad is 1, so 1. So there's 2 ways to get the dominant phenotype. There's this or this. So we add our probabilities together, 0 plus 1, and that's 1. That means 100% chance of having an individual with the dominant phenotype. And that was just from using our probability rules. Let's try a few more examples together. So we're going to do the big A, little a, crossed with little a cross. And we're going to figure out what are our chances of getting the individual with little a. So in this case, let's take a look at mom on the left and dad on the right. We need little a from mom and little a from dad. So for mom, there's half a chance of getting little a. From dad, there's 100% chance. So that's a half a chance, 50% chance. What are the chances of getting big A, little a? Well, in this case, there's only one way to form the heterozygous. Mom has to give the big A, and dad has to give little a. There's no other way it can form. Dad can't give you a big A. So what are the chances of getting big A from mom? Well, half a chance. Multiply by the chances of getting, and multiply by the chances of getting little a from dad, 100% chance. That's again half a chance, 50%. What are the chances of getting big A, big A? Well, that means you need big A from mom and big A from dad. So big A from mom is half a chance. Big A from dad, well, there's no big A there, so that's 0. And that's a 0% chance. What are the chances of obtaining the offspring with the recessive phenotype? Well, again, you need to think. Recessive phenotype means little a, little a. We already have that answer, half a chance. That was from question A. Chances of the dominant phenotype. Well, remember, dominant phenotype, there's 2 possibilities. There's big A, little a, or big A, big A. So first we'll find the probability of big A, little a. And from our previous question, that was a multiplication rule. We found half a chance. Probability of big A, well, we found from our previous question, that was the multiplication rule, 0% chance. Since there's 2 ways to have the dominant phenotype, but in this case, one of them 0% chance, it's just going to be half plus 0, which is half. So let's take a look at our Punnett square to see if we were right with that. So we have big A, little a at the top, little a on the side. We get big A, little a, big A, little a, little a, little a, little a, little a. And it looks like we're right. To get little a, it's a 50% chance. Big A, little a, it's 50% chance. And we had no big A at all. So we're right on all accounts, including the accounts down here. So without having to do a Punnett square, just by thinking with probability rules, we were able to figure out the answers to this. I know what you're thinking, Punnett square and this looks roughly similar in time, but trust me, when you get to dihybrid, tetrahybrid, trihybrid, it's a lot easier. So now let's take a look at this cross here, where we have a big A, little a, crossed with a big A, little a. So the first question is, what are the chances of getting an offspring with little a, little a? So to do that, let's call this one mom, let's call this one dad. You need little a from mom and little a from dad. It's and, so multiplication, A and D, multiplication. So half a chance to get little a from mom, multiplied, and half a chance to get little a from dad. That's a quarter chance, 1 out of 4, or 25% chance. What are the chances of getting the big A, little a genotype? So this is a situation where you need to be careful because there's two ways for this to happen. You can get the big A, little a genotype by getting big A from mom and little a from dad. Or you can get the big A, little a genotype by getting big A from dad and little a from mom. So let's try out those probabilities. First, what we're going to do is we're going to do the individual big A, little a from mom and dad, respectively. So for mom, big A, half a chance. From dad, little a, half a chance. So half times half is going to give you a quarter chance. Let's do the same thing for the dad and mom order this time, the other way around. So big A from dad, half a chance. Little a from mom, half a chance. And that'll be a quarter. Now, we want to figure out what are your total chances of getting a heterozygous. Well, since there's two ways for it to happen, this way or this way, we now add these two together, and we get 2 out of 4, which is half a chance, 50% chance. What are the chances of getting big A, big A? Well, the only way for that to happen is to get big A from mom and big A from dad. It has to be and big A from mom and big A from dad. So half a chance from mom times half a chance from dad, and that's 1/4. The chances of obtaining the offspring with the recessive phenotype, once again, you got to think, that means little a, little a. We already did this. We already did that. That was 1/4 chance. Now, what are the chances of obtaining offspring with the dominant phenotype? So there's two ways to get the dominant phenotype. We have big A, and we did that already. We did half a chance times half a chance, gives us a quarter chance. Or big A, little a in this situation. And in this situation, we found that to get big A, little a, we had to do our probability rules, but we got half a chance. So here we're asking the dominant phenotype, what are the chances of getting that? Well, there's two ways. There's big A, or big A, little a. So we have to use our addition rule here. A quarter plus half. That will be equal to 2 quarters. That was a half. I've made it 2 quarters. Plus 1/4 is equal to 3/4, which is 75%. And so if you remember your Punnett square, we found this right. We have our 3-to-1 ratio here. So we have big A, big A, big A, little a, big A, little a, little a, little a. All our answers are right on all accounts using the probability rules. Now here we have a different situation. We have a dihybrid cross. And so you're going to see how easy it is to do probability rules with dihybrid crosses. Now what I would do is I would treat each character as a separate cross. So in this situation, we want to figure out what are the chances of getting big A, big B, big B. So in order to do that, you need to get, let's call this one mom. Let's call this one dad. Let's start with big A chances here. So big A and big B and big B. So what are the chances of getting big A from mom? Well, that's half a chance. And big A from dad, well, that's 0. Dad doesn't have a big A to give. And big B from mom, because one of them has come from mom, that's half a chance. And big B from dad, that's 0, because there's no big B's there. So if you multiply anything by 0, it's going to give you your 0. What are the chances of getting little a, big B, little b genotype? So let's take a look. To get little a, one of your parents needs to give you little a. So our mom has to give us little a for sure. So there's half a chance there. Let's go to dad, and Dad has to give us a little a too, and Dad will always give us a little a because that's all he has, so that's 1. Let's go see if Mom can give us big B. Mom can give us big B, half a chance there. And then little b, can Dad give us little b? What are the chances? Yeah, the chances are that he can give us little b, and that's 100% chance from Dad. So this is half times 1 times half times 1, which is 1/4. 1/4 chance. And so you could figure out the probability using your Punnett square or using this probability rule here. The chances of getting an offspring with little a genotype. Little a, little b genotype. So to get this, you need little a from Mom, half a chance. Little a from Dad, 100% chance. And little b from Mom, half a chance. And little b from Dad, 100% chance. And that's 1/4 chance. 1/4 chance. What are the chances of obtaining an offspring with the recessive phenotype for both characters? So all that means is little a, little b, little b. So that we just actually answered in the previous question over here. Let's go take a look if we're right with our Punnett squares so far. So we have big A, big B as a gamete, that's possible. Big A, little b as a gamete, that's possible. Little a, big B. Little a, little b. And that's for this parent. For the other parent, it's just AB. So here we can get big A, big B, little b. Here we can get big A, little b, little b. Here we can get little a, big B, little b. And here we can get little everything. Little. Let's see if our little a, big B, little b is right. That is 1 out of 4. Yeah. And over here, little b, little b, is that right? Yes, that's also correct. So the chances of getting the dominant phenotype for both characters. So that basically just means this. Big A, something, big B, something. There's a few ways that can happen. There's AA, BB, that's a possibility. There's big A, big B, little b, that's a possibility. There's big A, big B, little b, that's another possibility. Or there's big A, little a, big B, big B. Those are all the different ways that can happen. Let's go take a look at each way individually if they're possible. I mean, do I even need to include some of these? In this situation, I can't get a big A, so that's a 0% chance. In this situation here, can I get big A, big B, little b? Yeah, I can get that in this situation, so that's a possibility. Can I get big A, big B, little b? No, I can't get this. I can't get big A, so 0% chance there. Can I get big A, big B, big B? No, I can't get that either. That's a 0% chance. So there's only really one way for me to have the dominant phenotype for both, and it's this method here. So what are my chances of getting big A, big B, little b? Well, for big A, little a, I have to get big A from Mom and little a from Dad. So it's half a chance from Mom times a whole chance from Dad, 100% chance to get little a, times half a chance to get big B from Mom, times 100% chance to get little b from Dad. And that's a 1/4 chance, 25%. Now, because there's so many ways to get the dominant phenotype, I use the OR rule. I can get this, or this, or this, or this. So what I'm doing is 0 plus 1/4 plus 0 plus 0, which is equal to 1/4 anyways. You always take a look at what the application is. If these actually were possibilities, then I would add those up to get those possibilities. But in this situation, this is the only one that's possible. You can just analyze it. You can say, well, to get dominant, what can I do? I only have this big A possible from mom, this big B possible from dad. There's only really one way for those things to happen. So now we have a bit of a more complex one, but it's still the same idea. You just have to be careful because you're dealing with heterozygous crosses for both situations. So let's take a look. So we're doing a big A, big B, little b, crossed with a big A, big B, little b. So let's see what are their chances of getting big A, big A, big B, big B, big B. To get big A, big A, big B, big B, so let's start with big A first. I need half a chance of getting big A from mom and half a chance of getting big A from dad. And then let's go to big B, and half a chance of getting big B from mom because there's either big B or little b, and half a chance of getting big B from dad. And so that is half times half times half times, that's 1 out of 16. If you remember, that's correct in our Punnett square for this 9-3-3-1 ratio that we had before. Chances of getting big A, big B, little b. You have to be very, 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 very careful here. Okay? So basically what that means is you want big A, and big B, little b. So find the probability of big A, and then find the probability of big B, little b, and then multiply them together. Because it's not big A, or big B, little b. It's you need big A, and big B, little b. So for big A, remember it's half a chance from mom to get big A times half a chance from dad. And that's 1/4. Okay. Now, what are our chances of getting big B, little b? Well, you have a big B, little b from mom here and a big B, little b from dad here. Remember that when you're doing a heterozygous cross, there's two ways to get big B, little b. You can get big B from mom, little b from dad, or big B from dad, little b from mom. So when you do that multiplication rule, you also have to do the addition rule, and just like you would see on previous slides, you would get half a chance. So what are the chances of big A, and big B, little b? Well, it's 1/4 times half, which is 1/8. If that was 16 individuals, that would be 2 individuals, and that does make sense according to our Punnett square. So I then multiplied these two together. I could have done it in one straight step. I could have done half a chance times half a chance for big A, then times half a chance for the big B, little b, and that would be 1/8. What are the chances of getting little a, little b, little b? Well, let's take a look. We have half a chance of getting little a from mom times half a chance of getting little a from dad times half a chance of getting little b from mom times half a chance of getting little b from dad, and that's 1/16. The chances of obtaining an offspring with the recessive phenotype for both characters, well, if you read that carefully, that's little a, little b, and that's 1/16. The chances of obtaining offspring with the dominant phenotype for both characters. So what that means is big A underscore big B underscore. So let's think about this carefully. Let's deal with those characters one at a time. Big A. You should know by now that when you have heterozygous crosses, the chances of getting the dominant for a monohybrid heterozygous cross is 3-to-1, 3 being that key word there. So we have 3/4 chances of getting that big A, little a all together. And the chances of getting a big B dominant phenotype, well, another heterozygous cross. That's another 3/4 chance. When you multiply, you get 9/16. So if you treat them individually, then it's very easy to do. There's another way to do this. It's a bit longer, but I can show you how to do it. So there's a few ways to get the dominant phenotype for all characters. You can have big A, big B, little b, or big A, big B, big B, or big A, big B, big B, or big A, big B, little b. Those are the different ways to get the dominant phenotype. Now, if you're an individual, you won't have all of these. You'll have one or the other. You'll have or. So I can use a multiplication rule to find the chances of getting these individually and then add them together, and you'll see that I will probably get 9/16 if I've done everything correctly. So what are the chances of getting this big A, big A, big B, little b? We already figured that out actually in a previous question. Did we do that? No, we didn't. So we'll just do it. I'll do the problem up here. So to get big A, big B, little b, you know that to get big A, little a from a big A, little a cross, it's half a chance. For the big B, little b, that's and half a chance. So that's going to be 1/4 chance over here. Big A, big B. Well, to get the big A, that's half a chance because that's heterozygous cross there. And then to get the big B, that's so half a chance for big A times half because you have half a chance of getting the big B from mom and dad, so that's 1/4, and that would be 1/8. And then to get big A, big B, we already figured out that was 1/16. And to get big A, big B, little b, that would be 1/4 times half, which is 1/8. When I say 1/4, it's because you have half a chance of getting this, and half a chance of getting this, and half a chance of getting this whole thing here. And so that would mean a 1/8 chance here. So now these are all the different ways to get the dominant for all. If you add all these up, you should get 9/16. So you can do it with fractions or you can do it with a calculator. So 1/4 plus 1/8 plus 1/16 plus 1/8 again. And you get 9/16 when you add them all up. So you can treat it like individual Punnett squares and then multiply them. Or you can do this rule here, which takes a bit more time. So you can do this with trihybrid crosses as well. And we'll do that example together. Again, you should be able to pause these videos and try them yourself to see if you're on the right track. Okay, so here we have a cross between this parent and this parent over here. Let's call this one mom again. Let's call this one dad. And so what we're going to do is we're going to answer some of these questions. So what are the chances of getting big A, big B, little b, big D, little d? So I'll do one character at a time. So to get big A, I have half a chance of getting big A from mom, 100% chance of getting little a from dad. So half times 1, that's half a chance for the, let me write that out here, half a chance for the big A, little a. Multiply that by, how do I get big B, little b? Well, half a chance to get big B from mom, 100% chance to get little b from dad, so half a chance for big B, little b, so and half a chance for that. And then let's see big D, little d. That's also half a chance, because half a chance here from mom, 100% chance there from dad. And that gives us 1/8 of a chance. What are the chances of getting an offspring with the little a, little b, little d, little d phenotype? So this is question A. Question B, you can try it out yourself. So let's start off one at a time here. how do you get little a? What are the chances there? Well, let's take a look. Half a chance from mom and times 1%, 100% chance from dad. So that's half a chance to get little a. And little b, same idea, half a chance as well. It's the same thing. And little d, half a chance as well, same thing. We get 1/8. What are your chances of getting an offspring that's recessive phenotype for all three characters? We already did it right here. Same thing. The chances of getting offspring with the dominant phenotype for, I should say all characters instead of both, so all characters. Okay, well, let's take a look. To have the dominant phenotype, so C we already did, I'll do D now. To have the dominant phenotype, you have to have big A, big B, big D. So what are the chances of getting the dominant phenotype for the A cross? Well, if you were doing the A cross, you need to get this big A from dad, so half a chance, and then you have no choice but to get little a from mom. So it's really half a chance to get that dominant phenotype from mom. Let's see for the A. For the B's, same idea, half a chance. For the D's, same idea, half a chance. And so we get, again, 1/8. Let's go to E next. What are the chances of obtaining an offspring with the dominant phenotype for characters A and B, but not for D? So basically we can get A underscore B underscore and then little d. So what are the chances that you get the dominant phenotype for A and B, but not for D? So that means we have little d here. So let's take a look. We want to know, how do we get the big A? Essentially, for this cross, what this really means is big A, big B, little d. So to get big A, we're just looking at big A, with little a first. That's half a chance. And to get big B, that's also half a chance. Half times 1, half a chance. And to get little d, well, that's also half a chance. Because it's half times 1. And that's 1/8, 1/8 chances of getting this genotype, which satisfies the phenotype described in the question. So I've included some more practice problems for you to attempt on the following slides. I'll put the answers there, but you should try them using the probability rules. So you should pause the video, try it out using probability rules. So I've included your answers plus what rule you're using, multiplication rule for those two, and then the multiplication and addition rule for these ones since it's a heterozygous cross. Here it's a similar question, just asked in different ways. I'll put the answers, but you should be able to attempt it and compare to my answers. Now here, pay close attention to the type of cross. You have big R, little r, cross with little r, little r. You need to figure out chance of getting big R, little r, and big R, little r. I'll walk you through this one. Pause the video, try it yourself, and then check your answer. So to get big R, you need big R from mom and big R from dad. to get big R from mom, you have half a chance, but from dad, you have 0% chance, so that's 0. Little r, you need little r from mom, little r from dad. Half a chance to get it from mom, and 100% chance from dad because that's all he has to give. For big R, little r here, there's only one way this can happen. You have to get the big R from mom and little r from dad. So you don't have to use the addition rule for this type of heterozygous because it's not a heterozygous cross. You just have to use your multiplication rule. So half a chance to get the big R from mom multiplied by 100% chance to get the little r from dad, and that's half a chance total. And again, here it's a similar question with the just worded differently. So pause the video, attempt it, and then compare your answers. So the dominant phenotype, in this situation, there's only really one way to get the dominant phenotype. It's the big R, little r. There's no way to get big R here. So that means we have our half a chance if you do your probability rules. Recessive phenotype, only one way. And that's also half a chance if you use your probability rules. Homozygous dominant, that's big R. No way to do that because father doesn't have big R to give you. And so that's 0. And again, there's a bunch more practice questions you can try. I'll put down the answers and then you can see if you're on the right track. Similar idea, just different words. I'll put down the answer again, pause the video, check if you're on the right track. So there's some more practice problems that you can attempt here with these crosses. Compare your answers with your peers to make sure you're on the right track. Using the probability rules will prevent you from having to make those huge Punnett squares that can be very tedious. It'll save you a lot of time and a lot of room on those tests, especially when you have short answer or long answer questions. And multiple choice, you don't have to waste your time doing a Punnett square. You can use the idea of these probability rules. This here is a good challenging one to do. I'll do one of the questions from here to show you how to attempt it, but it's the same idea. It's just a little bit more work. So let's try, actually, let's do B. We'll do B together. What are the chances of getting little a, big R, little b, big D, big D? So the chances of getting little a, let's start with that. Half a chance to get little a here, half a chance to get little a here. So you multiply those together, it's a quarter chance to get little a. And what are the chances to get big R, little r? Well, half a chance to get big R here, 100% chance to get little r there, so that's half a chance total, because it's half times 1. And what are the chances to get little b? Well, half a chance to get this little b here, and then 100% chance there, so it's a total of half. And what are the chances of getting big D? Well, it's half a chance here, and half a chance there. That's a quarter. And so we get half times a quarter. So that's 1 over 64 chances. I'll put down the answers for the rest, but I want you to attempt it yourself. So pause it and see if your answer is correct after. And then lastly, you have F, which is what is the fraction of the offspring from this cross that we predicted to have the recessive phenotype for all 4 characters? Well, that's your question C over here. So if you look at the question carefully, you have to interpret what the question's asking. So just to go over what I did for E, just in case you're unsure, big A, little a, the chance of getting a big A, little a from a big A, little a cross is half a chance because that's heterozygous. And the chance of getting big R, little r from the big R, little r, little r, little r is also half a chance. And big B, little b from the big B, little b, little b, little b cross is half a chance. And little d is a quarter chance because you have half a chance here and half a chance here. And that's 1/8 times 1 over 4, which is 1 over 32. Why did I put 0 here? Well, take a look. This spot is quite, there's 2 spots here where you have multiplied by 0. One of the parents can't give you big R, so you can't get big R there, and one of the parents can't give you big B, so you can't get big B there. So I know I'm going to multiply it by 0. I didn't even have to continue. I didn't even have to really care about what this number would be or what this number would be because I know I'd have to multiply it by 0. Or I knew I'd have to multiply by 0. So just a little cautionary note. Remember that these are simply probabilities or chances. You might be off from what you predict. It's kind of like flipping a coin. You can flip a coin twice or 3 times and get heads all 3 times. It doesn't mean it's a trick coin. It just means that it's a probability. So the more trials or sample size that you have, the larger the sample size, the closer you'll be to that probability. So if you flip the coin maybe 100 times, you might get closer to 50-50. You might not be right on, but you'll get closer. You might have 48-52. If you have 1,000, you might even be closer than that. So larger the sample size will mean that you're closer to that probability that you expect, but with 2 or 3, with chance, just due to random chance, you might be a little bit off. So what I would recommend that you do is you do the practice sheets that are given to you in class, and you also go back and just take a look at the problems you did before for trihybrid, for dihybrid, trihybrid, or monohybrid, and try them with probability. You did it with Punnett squares, then go see if you can support your Punnett square problems with probability. So again, go back and redo all those questions you did before using probability. Your test will be coming up soon, so it's a good idea to start studying for that test. You should be practicing problems throughout.